In a previous video that's linked here, I introduced the Beaglebone and showed you how you can access the input-output pins directly from the Unix shell using their sysfs mappings. In particular, I showed a short application on reading values in from a light-dependent resistor from one of the analog to digital converters. In this video, I'm going to look at how we can develop, deploy, and debug C or C++ applications on the Beaglebone platform. Why the C, C++ languages? Well, there are several languages available for programming on the Beaglebone, and indeed any embedded Linux device. However, C, C++ is a language that bridges the high level with the low level very well and is an ideal choice for embedded programming, especially where there are real-time or high-performance requirements. C++, as opposed to C, brings high-level, object-oriented concepts to the C programming language and brings scale to the applications that we might develop. To build applications in C, C++, we compile them using a compilation and linking process, which outputs platform-specific binary code. This means that an application compiled and linked under one architecture will not run under another architecture. In this video, I will look at cross-development, where we develop under one architecture but deploy to another architecture. The output from compilation linking and what we deploy is an executable application. While compilation and linking takes time, the executable application output contains native machine instructions that execute without the need for an interpreter with very high performance. In the video, I will show you how to develop applications directly on the Beaglebone platform itself, and then I'll go on to explain how you can cross-develop applications for the ARM platform. So, how can we take advantage of an integrated development environment, or IDE, on a desktop platform to develop applications that can be deployed directly to the Beaglebone? I will use Eclipse Cdt. The setup that I discuss isn't limited to the Beaglebone, but to any ARM platform using embedded Linux. Finally, I'll show you how we can use a debugger on a desktop PC to remotely debug an application that is actually running on the embedded Linux device. This is very useful, as in the example that I demonstrate to control the user LEDs on the Beaglebone, you can actually see the LEDs change as you step through the debug code. Okay, I'm just going to look at building a C++ application on the Beaglebone using editing the application on the Beaglebone and compiling the application on the Beaglebone. So this is fairly straightforward for a simple C++ application, but it doesn't scale very well. So let's have a look at how we could do this. Well, the first thing we need to do is connect to our Beaglebone. So I'm going to SSH to my Beaglebone, and I know that on my network it's 192.168.1.105, and I want to log in as Ubuntu. I have a Ubuntu installation on this particular Beaglebone. It's just the same if we were using Angstrom, it's the same steps you take. So let's just look at this. I have a blank account. So first thing we need to do, whether we're on Angstrom or on Ubuntu, is to install a C++ compiler. I'm going to use G++. So on Ubuntu we would type sudo apt get install, and in this case G++. It'll ask me for my password. I enter my password, and you'll see that in this case G++ is already the newest version. So in this case I have G++ installed on this particular Beaglebone, so it's all up to date and it's working. If you hadn't got it installed, this would go through the steps and download and install the G++ compiler on your machine. If you're in Angstrom, the way you would type it is opkg install G++. So pretty much the same steps, just slightly different package installer. Okay, so now once we have that installed, we need to edit the application. This is where it becomes quite tricky, because we have to use something like VI. And VI is a text editor that we can use directly in the terminal. So we can say VI, and we just call, I'll just do it in the root now. Perhaps I shouldn't, but let's just do it in the root. Test cpp a hash include iostream using namespace. Now this is a standard application in C++. iostream is the standard library that we want for input-output. Using namespace standard just means that we're using that namespace, so we don't have to explicitly write std : cout, for example. So we can then say int main for our typical C++ application. We can close curly brackets. Oh, this thing isn't working. Okay. A to add, and we can say cout, hello world. I'll call it Beagle World just to be. Okay. Okay. So that's my first application written. It's not the neat, it's not the most complicated. I just have to do, just to be consistent, return 0. Okay, so this isn't particularly nice. You have to know VI as well. Escape : WQ to quit, write and quit. So we can go there and just make sure it's correct. More test.cpp. So we can see our application, and perhaps there's a bit too much space there. Anyway, we can now go G++, test.cpp, and we'll give it an output file name. We'll call it test. Okay, capital T. So it compiles away, and hopefully there's no errors. There doesn't seem to be any errors. We can get it again, and we can see that our test has appeared. Here we've got our test application, and we can see that it's even got the executable flag set. So we can just execute this directly. So we can say ./test, and we should get hello Beaglebone world. So that's a first C++ application written at the command line on the Beaglebone using the VI editor in the Beaglebone. And you really have to learn VI if you're to use VI as a as your main editor. There is a better way, and that's what I'm going to show you next, which is where we cross compile. We develop our code on a different platform, and then we deploy our application to the Beaglebone. Here I'm using Virtualbox, which is a Oracle application that allows me to install Linux on my PC in a virtual environment, pretty much for like VMware. In this particular case, I've installed Ubuntu, and it's just the most recent version of Ubuntu. So I'm running Ubuntu Virtualbox 3.2.0, Linux 3.2.0, and I'm able now in here to install my Eclipse development environment. So I can just do that, sudo apt get install Eclipse, and this goes off. I have the latest version, so again we're okay in this particular case, but that will install the latest Eclipse in your environment. So I can then start this by Eclipse %. I'm just going to run it, and I've installed Eclipse Indigo. It's the latest version of Eclipse at this particular time. Select a workspace. So MalloyD workspace is okay. Okay, so it's my first time running Eclipse. I can close this, and I need to go help, install new software, and I want to install, in this case, I choose my releases. It's going to download the list of available software. My C++ development tools. Okay. This hover help, well, we'll install it, see if it works. C++ visual support, no, we'll leave it at that. Okay, so select those, go on to next. This will calculate my installation, so next. I've read it and I accept. Finish. It's installing my software. Okay, restart now. Okay, so I have my C++ development tools are now installed. Close this window, and I can now create a new C++ project. Before I go on though, I'm gonna quit out because there's one other plugin that I want for my Beaglebone development. I want to install, just check that everything's okay here. Yeah, I want to install this. I want to install my Remote System Explorer. It's a plugin for the Eclipse development environment. So I'm going to download this. Transfer it from the Irish site, and I'm going to open it. Okay. Okay. So this is opened with my archive manager and my Eclipse. and it has two directories, features and plugins. So I need to extract the features into my extract, and I need to install them into my .eclipse directory. Platform, and this is my features, so I need to install them here. Extract. Okay, close, and I need to go back, and the plugins, I need to do this into my, selected all these and extract these into my Eclipse, same directory, plugins. Okay, extract them here. Okay, successful extraction. So that means now that I have my RSC plugin installed, and you can download that. Just search for RSC or Target Management RSC or anything like that. You'll find this download link. Okay, there's that. So start up Eclipse again. This window down here is on my Beaglebone, and so that was where we had our test application. So just to show you, it's running on my test. Hello Beaglebone world. Okay, so we want to do the same thing, only we want to do it in our graphical user interface where we can build larger applications and more complex applications than having to use VI. So the first thing I'm going to do though is I'm going to go Window and show you, where is it? Other. Where are you? Remote System. Remote Systems, I think. Oh yeah, that's the one. I'm going to move it up here. Okay, so Remote System shows my local system. This is my local machine, which is on my PC, and I want to add in a connection to my Beaglebone. So I'm going to go New Connection, and the Beaglebone's a Linux system, so we're going to go Next, select Remote System type, it's Linux. Host name, well, we're going to put in the IP address, it's 192.168.1.105. Yeah. Okay. Next. We want to SSH files for our connection, our subsystem information. Process, it's shell Linux. Our shells, we're going to use SSH shells. Okay, next. Finish. I think we're done. Isn't too much to configure. Okay, it's set up. So the very first time now I connect to this, so this is my remote, I'll make a bit more space. This is my local system, and this is my remote system, which is my Beaglebone. Okay, I probably could have given it a name. I'll leave it as it is anyway for the moment. I should have given it a name. Can I edit it? Properties. I can. I'm going to give it a name. Okay. Okay, just to make it a bit clearer that I'm connecting to my Beaglebone. So here, when I go to this for the first time, hopefully it should ask me for a password. It does. So I'm going to log in. Well, I could log in as Malloyd. I have an account there, or Ubuntu. I'll use Malloyd. That's where I'm here, isn't it? Oh no, I'm logged in as Ubuntu. I'll log in as Ubuntu. And I'll save my user ID. I'll save the password. Probably big security hole, but I'll save it anyway. Okay, so that shows me the files that are there already. So you can see in my test and test CPP they appear because we have a connection, remote file connection to my Beaglebone. You can also do, so we'll create a folder here, new folder, and we'll call this Beagle. We'll just call it Hello World Test. Okay, to make sure we can do this on our machine. Okay. Okay, so there's no files in it. I can open up a terminal, which is very handy too. So I can open, connect, launch terminal. So straight at one click, I'm now logged into my Beaglebone directly, and I can see my Hello World Test. I can execute that, and that's Hello Beaglebone World, the one that we did earlier. So my folder is empty. So I'll leave that open as a terminal within Eclipse, and it means we don't have to open up a separate terminal there either. So that's my Beaglebone connection. Okay, so let's my shell process. Okay, so that's my connection setup. So now I'm going to set up a new project. And we're going to open up a C++ project. Next, and we're going to go with hello world, and we'll call it, what did I call it? Hello world test. My project name. Next, it's going to be license IP. It's going to be really important. Finish. Okay, so we're set up. Yeah, we'll say yeah. Okay. The only problem is, yeah, I've lost my window. Okay, I've just lost my window. I'll get it back. Not systems. I like it up here. Okay, so I've got my project, which is my C++ project, and my remote systems. Okay, so this project is working at the moment, and it all looks fine. The only problem is that this would be building for my Intel machine that I'm currently on. So if we were to build and execute this on our Beaglebone, it wouldn't run because it's not built for an ARM device. Okay, so we need to install our GCC. So this allows us to cross-compile to our ARM device. Okay, looks good. So once we've this installed, now we need to switch out our standard x86 compiler, or Linux x86 compiler, and we need to switch in our ARM compiler. So we're going to change our project settings. Select my project, properties, and I want to do a few things here. C++ build, settings. So my C++ compiler is going to be ARM, Linux, GNU, EABI, GCC, G++, sorry. And for my GNU C++ compiler, it's going to be that. ARM, Linux, GNU, EABI. Similarly for this. And finally for my assembler. Okay. Move over. Okay, so that's set. I also need to change my C++ includes because I need to paths and symbols. I need to change my libraries and my includes because at the moment now it's going for IA686, so we need to change this to our ARM. So if I go to my file system, it's in slash user nearby, and I'm installing for my C. So includes, and this is fine here. This is my includes are all there. Okay. Add to all configurations. Okay. C++. Add in my file system slash user include CPP 4.6.3. You can see there they're highlighted out because I can't select them, but you can see there's IOStream there, for example. Okay, so add to all configurations. Okay, and my library paths, I want to add in my file system user lib. Okay, add to all configurations. So now I've set up my includes and my libraries and my compiler, so I can go OK. Okay, that looks good so far. The libraries are there. My source file is here. And there's my project. So project build all. See what happens. Build all, parsing, invoking commands. And it looks like I have 0 problems. Building target hello world test, invoking GCC linker. Yeah, it's invoked the correct call. Hello world involved G++ was called correctly, the libraries called directly, it got correct. So all looking good. So hello world test. So that was the standard hello world, exclamation, exclamation, hello world. So you can see in the debug directory, we've got our hello world test, and you can see its target is ARM. So we should be able to execute this. Now, one way to execute it is to actually copy this. Now, there's got to be a better way to do this. If I copy this, I can go to my remote system, to my hello world test, and I can paste it here. Okay, so it pasted it there. Now, the only problem is that it pastes it without... Oh, well, I'll actually stay away from the shell. I'll use the shell that we have available. So SSH terminal. Disconnect, where is it? Oh, it's gone missing because I changed my view. Window, show view. Oh, where is my terminal? Other terminals. Just to put it back. Okay, so it's still there. So here we are, and you'll see I've copied in my file. Now the only problem is that the executable flag is missing. So we just have to chmod ugo +x hello world test. And then if we get a directory, you can see the executable tag is there, and we can just go .hello. Now you only have to do this once. So hello world. So you can see here, what's the advantage of this? Well, we're building on our Linux environment on our PC. We're writing our code here. We've all the facilities of our file managers, and we can open up any multiple files at the same time, link them together into our project. We can build it here. We can check for errors here. And when we're ready, we can actually deploy it to our remote connection and deploy it onto our remote machine and actually check that it works correctly. You can even set up a remote debugger to see what's going on the Beaglebone after you execute your application. There is one other way, which is to actually create the project. You should. Now, the problem is it's not working for me at the moment because there seems to be a problem with Indigo. But you should be able to do this. You should be able to go File, New, Project, C++ Project. And you should be able to actually say, well, we want to set up a new project called Hello World Remote. And browse, and actually now choose, oh, cancel. Why didn't that work? Change it to RSE, so Remote System, Browse. And we can actually choose our connection and actually create the files on our remote system and create our project on the remote system. In theory, this should work, and this should be very good because this would allow you then to write the code, compile the code directly on your remote system. But I'm having problems with the linker at the moment, and I think there's a bug in Indigo, in Eclipse Indigo, that seems to be causing a problem with this, and hopefully that will be resolved. However, there is a downside. The downside is that every time you want to compile, the files are going to be pulled back from your Beaglebone into your local memory to compile them. And also, it means that your project is tied directly to your Beaglebone, and should anything go wrong, your files are on your Beaglebone. And I think, in my case, I prefer to develop locally and then deploy remotely, rather than develop remotely and deploy remotely. So that shows you how you can get started with Eclipse and work with a C++ application in Eclipse, deploy to your Beaglebone, execute in your Beaglebone, and I suppose cross-compile your code within, more than anything else, cross-compile your code within the Eclipse platform. Okay, so let's do something a little bit more complex. So in this case, I'm going to flash the user LED 3, and I'm going to flash it first on for a second, off for a second, and I want to do this 10 times. So how do we do that within our C++ application? Well as including IOStream, I'm going to mix C and C++, so I'm also going to include stdio.h. So I'm going to mix C and C++ together for this application, so we're still fine. I'm going to give myself a bit more room. Okay. So here I am. So within my main, I'll leave my message there, hello world, And maybe I'll add in another message. I'll change it slightly. That's a standard message that comes with it. So we'll just call it LED flash start. And just to make sure that we know if it's working or not, I'm just going to put LED flash end, just so that I have an indication at the command line that my application is working. So in this case here, I'm going to set up a file handle. I'm going to use sysfs, and I'm going to use this to access the LED. So the way we could do this is we could say, for example, you know, in the same way as we use /sys/class/LEDs/Beaglebone user3, we can set up something like a file handle to access that particular location. So we can say file star LED. We'll call it the handle. This is our handle, our file handle, and initially it's null. It doesn't matter. And we can say let's set up a path, a character. We'll call it LED brightness because we want to access the brightness state. Sys class, the same way as we would have done this before, directly at the command line in our Beaglebone, and it was user3 and brightness. Okay, so we can see that on our board. Oh, I'm just switching into insert mode. Brightness, and we can see that if we go out to our terminal, we can see, well, cd/user/sys. We can see class. We can see our LEDs. We can see our Beaglebone user3. And then we can see our brightness, and we can do things like cat trigger. We can see what is the current situation on our Beaglebone. Who am I? Who am I again? Oh, Ubuntu. So we can do something like this. We can say, if we went to just affect the brightness, so we could say, for example, echo 1 to brightness. We can do this no problem on Angstrom if we're logged in as root. The problem is with Ubuntu, you have this pseudo notation. So we'd have to say something like this: sudo, what is it again? shc echo 1 to brightness. If we wanted to do this, so we have to actually connect in as root to do this. So at the moment my LED is off, my LED is on, and we can echo a 0 to brightness to turn the LED off. Okay, and that's working. Now the reason the sudo is coming in is because I just entered my password just a second ago, so my sudo is still active. It didn't prompt for a password. So you can see here it's important. Sudo is required if you want to access, and you can see why. You can see if you look at it, you see that we have no right access. The only part, if we look first brightness, the only right access is through the user root. So that does limit us, but perhaps it builds in a level of security that we might want. So it means that when we execute this application, we're going to have to execute it as root as well. So have I got that? Sys class, LEDs, Beaglebone, user3, brightness. Okay, so that's set up. So let's flash this LED 10 times. So we can say for int I is equal to 0. My fingers aren't working today. I is less than 10. I++, and we set up our loop. So we're going to do this 10 times, whatever operation we do on our LED. So we can say something like this: if our just do it into another level of detail, because we're going to say is equal to null. So we can say if our LED handle equals f open, or file open, our LED brightness, which is this character right here. This is the path to that, rather than type it, the full thing. And we want to open it with, we want to write access to it, and we want to say, well, if that's not equal to null, it means that we have opened up, created a file handle to this device, and it means now that we're able to write to this device. So let's try it. We can use fwrite. We want to write a 1, which is what we did at the command line, but we have to give the size of the value that we just wrote to it. So So the size of the type, which is character, so size type character, one byte, so we're sending it to LED handle. Okay, I think that is right. So that's our F write, that'll write a 1 directly to this device. And then we need to close the device. We close our handle, LED handle. So that will close it. Okay, now we want to see a delay of 1 second between this, so we can use a standard sleep that takes the number of seconds that we want to sleep for it. So we'll just use the standard sleep, which just makes it easy. We also want to specify it in seconds. So this comes from Untitled, which comes from Studio. That's handy actually. That's working correctly. My floating, actually that's working very well. That's in incubator stage within Eclipse, but it's very handy to have. So sleep, so we'll take this code again, and so that means we've turned on the LED for 1 second, and now we want to turn it off for 1 second. So it's screwed up the bit, so we'll just tidy this up. Okay, and in this case we're doing exactly the same thing, but in this case we're writing a 0, we're turning off the LED. Okay, just make sure this is all neat and tidy. I think that's it. I think that's my application. We're closing the LED handle. That looks good. So let's project build all. Oh, I didn't save it. Flip. Okay, so our console is going to give us. Oh, it worked well. I'm just going to make sure file save. Now build project build all. Okay, compiled, no problem. Built, no problem. And it's using the correct compiler. It's working correctly. So we can take this here from our debug release, and we can copy this file. Copy, and I'll go to my remote machine and into my folder. Paste. And I'll overwrite the hello world that was there. Okay, so that's done. And now I can go out to my terminal, and I'll just give myself a bit more space. And we can just go, oh, CD, I have to go home, back to my home directory, and I have to go into my hello world test. So you can see here's my hello world test, so I can go /hello world test. Oh, well, I can do this, press return, LED flash start. My LED isn't flashing. It's not flashing at all, and the reason is because I, as user Ubuntu, who am I don't have access to that particular sysfs handle, so I need to go sudo /hello world test, and if your timer hasn't started, now my LED is flashing, so that's working correctly. It's going to flash 10 times, so it's going to take 20 seconds to execute completely, and when it does, it'll say LED flash end. So that's my application written to access the input outputs. So there we go, it's stopped now and it's in its off state, the LED is off, and that's my application running and showing that you can build an application on a remote machine. So this is on my PC, compile it on the remote machine, copy it or deploy it to your Beaglebone, and execute it on your Beaglebone. And I think this is a much better way to write your C++ program than trying to use the shell and trying to do everything locally. It is also possible to install GNOME or gedit or some other development tools directly on the Beaglebone, but I think that if you can keep your development environment remote, it means you've got a separate backup of your files, you've got a separate location where you can build to multiple Beaglebones, if you have multiple Beaglebones, and work away like that. The final thing I'm going to look at in this video is the use of remote debugging. So ideally we're writing our code on our PC or our Linux machine PC, and we're deploying it to our Beaglebone, which is our remote machine. So if you want to call this as my local machine, and then the remote machine is my Beaglebone. It would be nice if we could debug our code on our local machine, but actually have it run on our Beaglebone directly. That's the ideal. Now, the documentation on setting up the debugger with Eclipse isn't that great, but here's one solution that I found. It may not be the best solution, but it's one solution that seems to work for me, is to use a combination of tools. So I'd like to use the debugger within Eclipse, but I'd like to execute the code on the Beaglebone while we're debugging. So to do this, I'm going to install apt-get install. I'm going to install the Gdb multi-arc, I think it's called Gdb multi-arc. So multi-architecture debugger. Okay, yeah, that's working. Okay, so that's correct. Gdb multi-arch. So that installs a multi-architecture debugger, and it's a standard package that you can install directly within Ubuntu. So this is on my my client machine, this is my PC, if you like. So what I'm going to do now, I'm going to, just to be careful, just be clear what I'm at now. I'm going to install. I'm going to log on to my Beaglebone. So connect to my Beaglebone. I'll just do it in another terminal just so it's very clear. SSH to my Beaglebone, which is 192.168.1.105, and I want to log in as Ubuntu. So here's my password. Okay, and on this machine I want to install the Gdb server. So sudo apt-get install Gdb server. Password. Okay, so that's going. So the idea is that on my Beaglebone, I'm going to run the Gdb server, and on the client machine, on the PC, I'm going to use a Gdb multi-architecture installation. GNU debugger. Okay. Okay, so that's installed. So we can execute that there. Now, just to keep it as neat as possible, I'm going to do the same as what I did before. I'm going to do this in a remote shell. So open up my remote terminal. So launch my terminal. Oh, so here we go. I hope I don't have multiple. Okay, anyway, we're fine. So ls. Okay, so I'll go into my hello world test, and I'm going to start up my debugger. Now, I'm going to make a mistake here on purpose. I'm going to set up my Gdb server. Gdb server, just call this so I can remember the options. I have to specify Gdb server, options, remote debug. I shouldn't have to do that. Attach IP. So I want to attach to my PC. Okay, so Gdb server 192.168.1.4. That's my PC on port 12345, and the application I want to run is called Hello. What's it called? Hello World. This is the application I'm going to debug. Hello World test. Okay, so that's working. So that's started up. This is on my Beaglebone. This is started up. My Gdb server is running, and it's running as process 1718, and it's listening on port 12345. So here we've got our source. So now I want to set up my project, and I've made a mistake here actually. I want to explain that this isn't going to work. Well, it's going to work, but it's not going to work properly. Gdb server. Okay. So go in here into my project, and I want to go into, run, debug configurations. And now what I want to do is my multi-architecture is installed. So go into my debugger, and instead of Gdb, I'm going to use Gdb multi-arch, my multiple architecture debugger. And then I need to set up a connection. So my connection is going to be to my Beaglebone, which is 192.168.1.5, port number 12345. Okay. Let's go. I think that's it. Debug. Come on. Oh, what's wrong? Details. Oh, the IP address wrong. Run. I entered the IP address wrong. Debug configurations. Go back down here. Debugger. Connection. Oh, 105. 105. Okay. Debug. Okay, so this is working. So it's received a remote connection. That's right. We'll switch our perspective to debug configuration, so it's switched my view. The only problem with this, I'm after losing my shell, so I need to go Window, Show View, where's my console? Terminal. Okay, so here's my terminal. Okay, so you can see remote debugging from host 192.168.1.4. So we're ready to go. So my start point here is now inside my main, and you can see I've got my LED handle as a file, LED brightness character. So we'll step through. So this is now executing my code. This is my Beaglebone. This is directly on my Beaglebone, and this is my debugger running on my PC. So we can step through now, and we can go step over. So start, see out, and you can see there's the effect straight away. We can see that we get the output on our Beaglebone. We've got LED flash start has come up, and we can see our disassembly instructions. Still no variables. We execute through here. Character LED brightness should be this. Step into this, and you can see that that's set that flag there. You can see we're about to start and use int. Int is set as an initial value of 34425, which isn't good news. But you'll see that when we step into this, we can see int goes to 0. So it's debugging. Everything's working correctly. Everything is displaying correctly. However, I've got a problem, and here's my first problem. If LED handle F open brightness or plus null, you can see that we step into this. Let's step into this, and you can see. Oh, that didn't press it. Step into this. And you can see we have a problem. Okay, so stop this, stop everything, and go back to my C configuration, and go back to my terminal. It's killed my application, and everything is still in order, and there's a reason for it. The reason that we've got a problem. I don't want to view the assembly. Stop that. The reason is because, well, Hello World test wasn't running as root, so therefore had no access to the location where we had our user LED, so there was going to be nothing happening. So we can run this as sudo Gdb Server. Okay, sudo Gdb Server, password. Okay, so now this is running again on the port. And let's debug it. So project run debug. Okay, switch to my debug configuration. So connect to the we'll switch automatically. Okay, so now this time let's step over it again. So everything looks okay. We can start stepping over, and this time you'll see that when we step over, our file handle's been set. Setting our file location, going into our loop, into set to 0, so this is going to loop 10 times. And now we're going to try and open our file, which is sysclass LEDS, SSFS. And we step into this, and you can see that this time we're into this loop, and we're going to write a 1 now to our LED handle. And on my Beaglebone, when I do this, when I step over this, nothing happens so far. It hasn't lit the LED. Oh yeah, of course, sure. F close has to happen. So hit F close, and yes, my LED is on my board. So the LED is lit up, and everything is working correctly. So it means I'm debugging now, and then go through this loop. You can see our int is 0. We go step into this. Still my LED is still on. I'm gonna write 0, close it, and my LED is now off. Sleep for 1. And it's going to loop around again, and now you can see that the int changes to a value of 1, and we're going to continue around. So this application is working perfectly on the Beaglebone. It's lighting the LED, turning on and off the LED. I can see what's going on in my application. I can look at my variables, and I'm quite happy now with this debug configuration, because it allows me to see the physical change on the Beaglebone, and also to see what's happening inside my code as I continue on. And you can do everything that you can do normally with a debug environment, set your breakpoints and so on. So hopefully you found this to be a useful introduction into C and C++ on the Beaglebone, and especially in relation to cross development. I'm planning to build more videos on C, C++ development on the Beaglebone, especially in dealing with the input-output side. and I'll link those videos here when they're available. But for the moment, you can go back to the main index and see the other videos that are available.